Hello everyone. The subject is EC3501 Wireless Communication. Unit 3 is Modulation Techniques, Equalization and Diversity. Now we are going to see the topic Diversity Techniques. These are the topics in third unit. Let's start with Diversity Techniques. The powerful communication receiver technique that provides wireless communication link improvement at low cost is diversity technique. It requires no training overhead since training sequences are not required. It can provide significant link improvement with little added cost. The diversity decisions are made by the receiver and are unknown to the transmitter. So let's see the concept of diversity. If one radio path undergoes a deep fade, another independent path may have a strong signal. By having more than one path to select from, both the instantaneous and average SNR at the receiver may be improved, often by as much as 20 dB to 30 dB. There are two types of diversity. One is microscopic diversity and second one is macroscopic diversity. Microscopic diversity is used for small scale fading and macroscopic diversity is used for large scale fading. Now let's see about the practical space diversity techniques. It is also known as antenna diversity. It is a popular diversity used in wireless systems. It is used in base station design. At each cell site, multiple base station receiving antennas are used to provide diversity reception. Base station antennas are spaced far apart to achieve decorrelation. Separations on the order of several tons of wavelength are required at the base station. So this is the block diagram for space diversity. There are multiple antennas, M antennas are present and they have variable gain, and there is a switching logic or demodulator, and finally we have the output. So in space diversity we have four types: selection diversity, feedback diversity, maximal ratio combining and equal gain diversity. Let's start with selection diversity. It is the simplest diversity technique. M modulators are used to provide M diversity branches whose gains are adjusted to provide same average SNR for each branch. Receiver branch having the highest instantaneous SNR is connected to the demodulator. Antenna signals themselves could be sampled and the best one is sent to the single demodulation process. And this is the block diagram of selection diversity technique. The same thing, there are M antennas with variable gain and then we have the demodulator. And the selection diversity is the simplest diversity technique. Receiver branch having the highest instantaneous SNR is connected to the demodulator. The antenna signals themselves could be sampled and the best one is sent to the single demodulation. And second one is feedback or scanning diversity. It is similar to selection diversity except that instead of using the best of M signals are scanned in fixed sequence until one is found to be above a predetermined threshold. The signal that is the best of M signals is received until it falls below threshold and the scanning process is again initiated. So let's see the advantages and disadvantages of feedback or scanning diversity. It is very simple to implement and only one receiver is used. These are the advantages. And if you see the disadvantage, that is the resulting fading statistics are inferior to those obtained by other methods. And this is a basic form of scanning diversity. Here we have antennas, we have the comparator, we have the receiver. This is the block diagram, a basic form of scanning diversity. Next, let's see about the maximal ratio combining. In maximal ratio combining, the signals from all of the M branches are weighted according to their signal voltage, to noise power ratios and then summed. So this is the diagram. Here the signal from all the branches are weighted according to their signal voltage to noise power ratio and they are added. So here individual signals are co-phased before adding, which requires an individual receiver and phasing circuit for each antenna element. It produces an output SNR equal to the sum of the individual SNR. So the advantages of maximal ratio combining is it produces an output with an acceptable SNR even when none of the individual signals themselves are acceptable. It gives best statistical reduction of fading of any known linear diversity combiner. Then we have the equal gain diversity. In certain cases, it is not convenient to provide for the variable weighting capability required for through maximal ratio combining. In such cases, branch weights are all set to unity, but the signal from each are cophased to provide equal gain combining diversity. It allows receiver to exploit signals that are simultaneously received on each branch. So the performance of equal gain diversity is marginally inferior to maximal ratio combining but superior to selection diversity. At base station, space diversity is less practical than at mobile because of two reasons. One is narrow angle of incident fields requires large antenna spacing, and second one is the high cost. So polarization diversity can be used in base station. There are several types of polarization diversity. One is linear polarization and second one is circular polarization. In the case of linear polarization, we have vertical and horizontal. In the case of circular polarization, we have right-handed and left-handed polarization. So let's assume that the signal is transmitted from a mobile with vertical or horizontal polarization. It is received at the base station by a polarization diversity antenna with two branches. So this is the figure. It is the model for base station polarization diversity. So the polarization diversity antenna is composed of two antenna elements V1 and V2, which makes polarization angle plus or minus alpha with y-axis. It is represented in the diagram. The angle is alpha. Mobile station is located in the direction of offset beta angle from the main beam direction of the diversity antenna. The angle beta is also represented in this diagram. Some of the vertically polarized signals transmitted are converted into horizontal polarized signal because of multipath propagation. So the signal arriving at the base station can be expressed as x and y. The expressions of x and y are given. Here x and y are signal levels received at beta is equal to 0. Let's assume R1 and R2 have independent Rayleigh distribution and pi1 and pi2 have independent uniform distribution. So the received signal at elements V1 and V2 can be written as this equation. These are the two equations that represents the received signal at elements V1 and V2. And then the correlation coefficient rho is calculated and it is written. The equation is given. So the correlation coefficient is determined by three factors. One is polarization angle, second one is offset angle, and third one is cross polarization discrimination. The correlation coefficient becomes higher as offset angle beta becomes larger. Rho becomes lower as polarization angle alpha increases. This is because the horizontal polarization component becomes larger as alpha increases. Because antenna elements V1, V2 are polarized at plus or minus alpha to the vertical, the received signal is lower than that received by a vertically polarized antenna. The average value of signal loss L relative to that received using the vertically polarization antenna is given by capital L. The equation is given. And second one is about frequency diversity. Frequency diversity transmits information on one or more carrier frequency. Frequencies separated by more than the coherence bandwidth of this channel will not experience the same fades. It is employed in microwave line of sight links which carry several channels in FDM mode. The disadvantages of frequency diversity techniques are it requires spare bandwidth, it requires more receivers. And then we have the time diversity techniques. Time diversity repeatedly transmits information at time spacing that exceed the coherence time of the channel, so that multiple repetitions of the signal will be received with independent fading conditions, thereby providing diversity. Implementation of time diversity involves the use of the rack receiver for spread spectrum CDMA, where the multipath channel provides redundancy in the transmitted message. So this is taken from the textbook Wireless Communication by Rappaport. Thank you.